sine wave. The wave forms by an alternating current or voltage is called sine wave. An alternating current or voltage is one which periodically reverses its direction in a regular manner, the general shape of a sine wave, which can be either current or voltage. Notice how the voltage or current varies with time. Starting at 0, it increases to a positive maximum, peak, returns to 0, and then increases to a negative maximum, peak before returning again to 0. Phasor representation of a sine wave. A full cycle of a sine wave can be represented by rotation of a phasor through 360 degrees. The phasor trace out the sine wave as it goes for 0 degree to 360 degree. The length of the phasor is equal to the peak value of the sine wave. Observe the 90 degree and the 270 degree. The angle of the phasor measured from 0 degree is the corresponding angular point on the sine wave. Cycle. A cycle is one complete set of positive and negative value of alternating current voltage. It can also be defined as cycle as defined as included the variation between two success points having the same value and the same direction. Its unit is cycle. Wavelength. The distance covered by one cycle is called wavelength. Its unit is meter or centimeter. Wavelength equals velocity frequency, where symbol of wavelength is Greek letter lambda. Note, the velocity of radio wave is example. Time period. Time taken to complete one cycle is called time period, or the time interval between successive repetition of a periodic waveform. The time period and frequency are reciprocal to each other. T equals 1/f. Higher the frequency, shorter the time period. Second is the basic unit. Smaller units are used such millisecond, microsecond and nanosecond. Frequency. The number of cycle per second is called frequency. The more cycles completed in 1 second, the higher the frequency. Frequency is measured in units of Hertz, abbreviated Hertz. Hertz. 1 Hertz is equivalent to 1 cycle per second. The symbol for frequency is FF equals 1/T. Hence the frequency of waveform is 1 Hertz whose time period is 1 second. AC sine wave from sinusoidal, square and SAWTOT. The shape of the alternating voltage or current graph is called waveform. 3 voltage AC sine wave from AC sine waveform sinusoidal, square sawtooth. Instantaneous value. The value of alternating current or voltage is continuously changing. Hence the instantaneous value is that value of alternating current or voltage at any particular instant. Instantaneous current is denoted by the symbol I and instantaneous voltage by V. This instantaneous value is different at different points along the curve. Instantaneous values are positive during the positive alternation and negative during the negative alternation. Peak value. The peak value of an alternating quantity is the maximum value reached, either positive or negative, during a cycle, since the peaks are equal in magnitude. A sine wave is characterized by a single peak value as constant and represented by Vp or I. Peak to peak value is the voltage or current from the positive peak to the negative peak of courses. It is always twice the peak value is expressed in the following equation: average of value. An arithmetic average of all the value in a sine wave for one alternating is called average of value. The average of a sine wave taken over one cycle is always 0, because the positive value above the zero crossing offset the negative value below the zero crossing. To be useful for comparison purposes, the average of value of a sine wave is defined over a half cycle rather than over a full cycle. The average of value is the total area under the half cycle curve divided by the distance of the curve along the horizontal axis. The result is expressed in terms of the peak value as follows for both voltage and current RMS values. The term RMS stands for root mean square. It refers to the mathematical process by which this value is derived. The RMS value is also referred to as the effective value. The RMS value of a sine wave is actually a measure of the heating effect of the sine wave when a resistor is connected across an AC sine wave voltage source. Then a certain amount of heat is generated by the power in the resistor. If the same resistor is connected across a DC voltage source, the value of the AC voltage can be adjusted so that the resistor gives off the same amount of heat as it does when connected to DC source. The RMS value of a sine wave is equal to the DC voltage that produces the same amount of heat as the sinusoidal voltage. The peak value of a sine wave can be converted to the corresponding RMS value using the following relationship for either voltage or current. Using their formulas, can be determined the peak value knowing the RMS value as follows. Similarly, to find the peak-to-peak value, simply double the peak value. Describe audio and radio frequency and their wavelength. The entire frequency range of alternating current or voltage is from 1 Hertz to many is divided into many groups. Audio frequency, AF. Audio frequency is the frequency which can be heard by our ear ranging from 16 to 1600 Hertz. Treble tone is produced at the frequency of 3000 Hertz or above. Bass tone is produced at the frequency of 300 Hz or low. Loudness is produced by amplitude. More the amplitude of audio frequency, more the loudness in the audible sound. Radio frequency. Above this audio frequency range up to several thousand megahertz is the radio frequency, RF, band, which is used for all forms of radio communication generally. Above than 300 GHz. The frequency will not be included in radio wave. Wavelength of audio frequency. Draw the electromagnetic wave spectrum. At different frequencies, waveform have different characteristics. The total range of alternating current AC frequencies run from 0 Hz up through 10-22 Hz. This full range is known as the electromagnetic wave spectrum.